Hey, my name is Scott Chacon. I'm the CEO of Git Butler, and I also happen to be a certified wine expert. And today we're going to be sitting down with Caleb, much like I'm sitting down with these street tacos, to talk about libgit2 and building our own Git client. So strap in. Hello, welcome to Bits and Booze. My name is Scott. I have with me today, once again, Caleb.
Hello.
A fellow butler. We're ready to go further into our Building a Tory app.
Indeed.
And today, what are we going to be looking at? We're going to be looking at one of our favorite libraries, which is
Git2, which is a wrapper around libgit2 for Rust.
Genau. We're going to take what we did last time, which was build sort of a generic Tory app, and we'll make it a Git client.
Yeah.
And so, as it's Bits and Booze, we have some booze, although we have a very special booze today.
Indeed.
So this is the first in the history of the Bits and Booze series, which is a non-alcoholic wine. And actually, most people probably don't know that there are non-alcoholic wines. They're not super common. Although, in Berlin, I have, like in November, I didn't drink at all. And so when I'd go to a restaurant or something like that, I'd ask, if there's like and actually most restaurants in Berlin do have at least one non-alcoholic wine. So we have, actually, I believe this is a German company, Knoll Wines. Okay. This is a Verdejo. So this is a Spanish grape, generally. And the way that they make this wine, actually, do you know how they make a non-alcoholic wine?
So I listened to a podcast on beer making a while ago where they talked about there being some sort of yeast types that tend not to make as much alcohol.
That cannot possibly be true. I'm fascinated by that.
Yeah.
Well, I mean, the whole point of yeast is that it eats sugar to create alcohol and carbon dioxide, right? So how would you have a yeast type that doesn't create alcohol? Anyways,
no.
The way that they do this, cheers.
Cheers.
See how it tastes.
It doesn't really taste of anything.
I mean, it tastes like wine. It's missing a bite, right?
I've had grape juice with more flavor.
So I would say that we're not overwhelmed. If you're at a party and you're trying not to drink alcohol, and you have a nice glass of wine, it looks like a glass of wine.
It does,
And it tastes wine-ish.
Yeah, adjacent.
It tastes wine adjacent. So the way that they do this, essentially, is they make a real wine.
Yeah.
Like a 12, 13% alcohol wine. And then they put it under vacuum.
Oh.
And then they sort of reverse distill the alcohol fumes like out of
it's got a lower boiling point.
Right.
Yeah.
Right. And so they put it under like a heavy vacuum and they essentially like suck the alcohol out of the wine and they get it down to 0.3 or something, right? So less than 1/3 of alcohol instead of 13 or 14 or 15. If you're gonna drink something that looks like alcohol and is not alcoholic, I feel like alcohol-free beers is much better. Like they taste very close to beers. Yeah. Like I actually really enjoy them. I drink them at home a lot. But this works. What are we doing today? We're doing libgit2.
Indeed.
We're doing Git2.
Yeah.
Rust crate.
I think the idea for today is that we're just going to install the Git2 crate and then sort of use it to sort of inspect the state of a Git repository.
Yeah, so let's do like a branch inspector app.
Yeah.
All right, so how do we start with libgit2? Can we introduce libgit2 a little bit first?
Sure.
Actually, I can do
you
this.
Can do that.
You talk most of the time. Actually, I mean, I bullshit a lot here. So libgit2 is a project I actually kind of helped usher along in the early days at GitHub. It was started by Sean Pierce a long time ago, probably 12, 15 years ago. I don't know if you know this. I was a Google Summer of Code mentor for a C project. That is the correct interpretation of that information. Vicent Marty was my student, and we essentially like convinced him to leave his like he was going to university and trying to get like a PhD or something or a master's degree, and we pulled him out and was like, no, you should work at GitHub instead. But yeah, he worked on libgit2 for me, for GitHub at the time, and was trying to make it into a real library. And it's grown up over the years. Yeah. There's a lot of people at GitHub and Microsoft and other companies now that have worked on this library. But now, again, like 10 years later, we're taking advantage of it once again to write our Git client. But it's essentially a pure C implementation of a lot of the stuff that Git does in a reentrant library that you can bind to in a safe way, which is not how Git is written.
No.
So this is the Rust binding, which is actually a very good binding. Like there's lots of languages that bind to this. Rust is one of the best ones. I think GitHub professionally maintains the Ruby library, Rugged. The .NET library, I think, Git.net or something. I think Phil.
Why do they do that?
Because we had GitHub Desktop that was trying to use this, and so we had like a sort of Electron-ish version. Well, at the time there were different builds, and then it went into Electron at some point. But like, so it ended up being the Node one. But I think they because of that they maintain the Ruby one because we'd use it for the server. The .NET one because of the GitHub Desktop, and then I think the Node one or something. I'm not sure. But anyways, this is the Rust one, and part of the reason that it's very, very good is because Cargo uses this, right? So Cargo uses Git for a lot of stuff, and it uses the Git2 library for a lot of the stuff that it does in the background. Anyways, that's the background. Now, let's put it in our project and start using it to actually make this a Git client.
Cool. So the first thing we want to do is we just want to install the library itself. So I'm going to go to my cargo.toml, which is like a packaged JSON if you do JavaScript, or a gem file if you do Ruby. And this just declares, what my dependencies are. So I want to install Git2, and I think the latest version is 19. So I can just come in here and say Git2.
Do you have to specify the version?
I think you can sort of say do a range or do sort of like fuzzy match the patch or something. But I don't remember the syntax for that.
Should we see if that works?
Yeah.
All right. How do we see if it works?
So you can see at the bottom I've got Rust Analyzer installed, which is a tool that sort of is like a language server for Rust. And you can see it going and recompiling the app. If I also take a look where I ran it, you can see that, it was sort of
restarted
in the middle of compiling, and it's completed successfully, which means that it's installed the app. You can see it's compiled.
Oh, yeah, I can see libgit2 in there. You can see it pulling other stuff. Okay.
Yeah. So I already have this little Rust function that we made in last episode, list files. And I've adapted it so we just have this little sort of output struct, so we can just add some extra little properties in there.
Now let's just list the branches. How would we list the branches in Git2?
Yeah, so the first thing I want to do is just to, first I'm going to just get rid of the sort of things I had before, and just, for now, just return a empty vector, so Rust doesn't
work.
Yeah. And what I want to do is open the repository. So this is kind of like just CDing and then being able to use Git commands. So what I want to just do is say, let my repo
go.
What?
Nothing. It was a Moses joke. Let my repo go.
Oh, I get it. I do get it. I say let repo equals a Git2 repository, and now I just want to use the sort of : open to open it. And this just takes a string, so it's super easy to use.
And this is actually very nice. I've used this before. This is actually very nice. Again, unwrap. This is very nice because it can be a bare directory. It can be, I think, even a subdirectory, and it will look like down directories until it finds a Git repository, right? So it's relatively smart about, you can give it almost any path, and it's like, what is the Git repository that is here-ish, right?
Yeah.
Okay, so now we have a repo object, and from working with this, like most of the stuff you do with libgit2 is off of this repo object.
Correct.
There's like a ton of stuff you do here. So in libgit2, how would you say, what are my branches?
So libgit2 provides this really handy method called branches, which pretty much does what it says on the tin. So
Unintuitive.
I can say repo.branches, and this will return a sort of iterator of all of the branches in my repository.
Okay, so now there's a filter option in that, which is the branch type.
Right.
So normally when you run git branch, it's only going to show you the local ones.
Correct.
Or you can do -r for the remote ones or -a for all of them. What are we going to show here? Just the local ones?
I think let's just do everything.
Okay, let's do everything. Do you have to do a special filter type for that? Okay.
So if you see in the function signature, it's got a option of a branch type.
Yeah.
So this is kind of like in Ruby where something might just be there or it might be nil.
Yeah.
Rust doesn't have the concept of nil, so we've got to have something either be some type or none. Right. So we're just able to say none.
And none means just show every branch reference so you can find. Okay, so let's show all the branches.
So I first need to unwrap that, and then I'm going to, sort of like last time, use the map function to convert my branches into sort of...
So what does the branch object look like that comes back?
So the... One second.
I mean, it must have a branch name. It must have a SHA that it points to. It must have probably a tracking branch, maybe, if it exists, if it's a remote.
Yeah. So I believe we just get the branch struct, which is sort of a little bit of a wrapper around the reference. So this lets us sort of get the branch name.
Okay.
Also see sort of so where, like, what is the head of that branch? So what is the top commit in that branch as well? So if I access the branch, I need to unwrap this first. So with Rust, we're going to be very, very particular about if we've got something that might fail, we need to either handle the error or just say, don't worry about it. So because this is a little...
Again, I feel like we need to put like a big disclaimer on this that's like, don't unwrap your shit, probably. Yeah. We're just doing this for the purposes of demonstration. Yeah. Like it should probably return like a result and you do like a question mark or something that bubbles the error up so you can handle it properly. But yeah, okay. Well, we can do Rust error handling in a different episode. Don't do what we're doing.
Yeah. Never
do as we say, not as we do. No, that's not the is that the phrase?
Do as I say, not as you do.
Yeah, that is. Yeah. Okay. Yeah. And we're saying don't do it.
Yeah.
But what we're doing is doing it.
Yeah.
Okay.
So I have this branch object which allows me to sort of access a bunch of information about a branch.
Sure.
I've actually got
collected at the end there.
Yeah. So what I'm first going to do is just sort of dig in, unwrap, and grab the sort of branch because it gives me a little more data that I don't quite need. And what I want to do first is to just sort of list out what are all the branches. So I'm going to change my output struct just to sort of have the branch sort of reference, which I'm going to call ref. Sure. And now I can just say output, which is the name of my struct. There we go. So.
Oh, interesting. Why do you suppose that is?
Because you can have I think a reference type.
Okay. It's a keyword.
It's a keyword. Yeah. So I want to just access on the branch. I want to get the name. So I'm going to say
do you have to do as string or something?
Name, which is a result of an option of a stir.
Some more of this delicious.
So I can just do multiple unwraps and then call dot to string, which converts a stir to a string.
I don't think we're selling anybody on Rust at this point. Unwrap, unwrap, unwrap.
So there are utilities that we use in Git Butler, like the anyhow library, that makes this very easy to work with, but sort of Tauri sort of on its own doesn't sort of package those, so you can sort of choose how you want to do that.
Yeah. All right. So we got our simple reference name.
Yeah.
Does this work?
Probably. So let's just copy a repository URL.
Yep.
Let's go paste this into this lovely input. And now if I hit this button, we see a list of references.
Oh, we do.
Yeah.
Can we show that in the UI? Let's take a minute to actually not have to console log.
To show this in the UI, we want to, rather than just sort of assign it to a sort of variable in here, we want to declare something with the Rust state. So in order to do that first, because this is an object, we need to just tell TypeScript what kind of object is this.
So it's some array.
Yeah. So I want to say, give me a interface of our sort of output, which at the minute just has one property, which is reference.
It
was too far over. So reference as a string, and now I can say let just outputs equals a new state, which is of the type output array. and we can just give it a
And then
default
anytime
array.
you change that, it re-renders the component.
Correct.
All right, so we're going to re-render that when we get info. We'll throw something in outputs. It'll be like, okay, it's time to re-render because we have something.
So we can now tell it what it is. So we're now assigning to outputs, and now we can go and use some of the templating in Svelte to sort of list all of those out. So what we want to do is say each.
I always forget the syntax, by the way.
It's really bad syntax.
Like if, and then it's like colon else or something, and then backslash if. God, it's so dumb.
The fact that it's also each outputs, like your each array as object, which is reversed from every other programming language I know.
It is real. Okay, but anyways, it's great.
So each outputs
as
just output.
Output.
Let's close that off. We can then sort of structure this as a list. So I'll say it's a unordered list with a list item inside, which let's just unpack the output.reference. So now if we come back to our app, we can paste in our URL, click for the list, and it's outputting our items.
That's very nice. We should probably default that so every time we rewrite this, we don't have to put that URL back in.
Let's do that. That's a good idea. So where we've just got an empty string here, I can just default it to an existing string.
Look at how cute that is.
And
now we're listing out the branches. Let's do maybe one or two more things of just some interesting things we can do with Git or Git2. I've always liked this concept of ahead behind information. So if you go to like GitHub and you see sort of a list of branches, you can see for each branch, if there's some, I guess we're going to have to say what a main branch is, right? It has to have something compared to.
Sure.
So maybe we put in like a main branch name, or we just guess it.
Let's just pick whatever I chose as my main branch.
Yeah, that's a good point.
Which
I mean, it's either origin main or origin master generally, right?
Yeah.
So what do you have?
I think in my case I've got main, so we can just look that up. So in order to look up a branch, repo.findBranch, and this allows me to just give it a branch name. So I want to say main, and then it wants a branch type. So we know that this is a local branch because we don't have sort of origin in front of it. So I'm just going to say...
I was going to say, normally you kind of want this to be the remote, right? Like in Gitbutler, all of the branches are calculated off the remote because it's like whatever sort of... Well, I guess it depends on what we're looking at. But yes, for the most part, you kind of want it to be what is the production branch and how have these things changed, right? So, okay, but in this case, we don't have a remote, so it's going to be a local branch. So how do you do that?
So I just want to say git2 branch type, which is this sort of enum type structure. And I can then just say, look for a local branch.
Right.
And I'll unwrap that.
Because it's always there.
Because it's always there. And let's say main.
As we say.
Branch.
Not as we do. Actually, we probably have to just quit if it is the main, if it is the same, right? Because we should get the main branch in here. So is there a way to like map to nothing or something? How would you sort of say nil and then like compact or something?
If we want to do a map, but we want to skip certain entries, we can do what's called a filter map.
Oh yeah, you filtered before.
Filter map. And this expects us to now return optional. So if we provide a value, it will...
Some or a none?
Yeah, a some or a none.
All right, so we're going to do some output if it's cool and a none if it's the main branch, so we don't include it in the list.
If main branch dot name is, I should be able to just equate it to branch dot name. And if that holds true, we're just going to return none. And that means that it will just skip out the main branch entry.
That matches. Okay. And then for the rest of them,
we can
we're going to do... Nice.
So
it takes out missing.
Yeah.
All right. So now for the rest of them, we're going to do... I like I said, I always like ahead behind information. So essentially what we want to say is how many commits are on this branch that are not on main branch, and how many commits are on main branch that aren't on this branch. So this is actually a not uncomplicated query, right? Because we have to create a walker, like we have to go through commits on one until we hit some sort of common ancestor of the other one, right? So that is not. It seems difficult, but so how would we do that?
So we could start off some revwalks, but Git2 actually provides us a utility that just does this for us.
Oh my god, that's so boring. Let's do
wanna
it the old way.
Okay. Okay.
I don't want to cheat. I don't want to use the cheat thing.
I'm going to need 5 minutes to look up the document.
No, you don't.
Okay.
Do a rev walker. Let's fucking do it.
So I'm going to make a new revwalk. So I'm going to say let walker equals repo dot.
Can you call it Walker Texas Ranger?
No. So I'm going to say revwalk. So this creates a new walker of the repository. I need to just unwrap it. Sure. And we want to just declare this as mutable because we're sort of going to be pushing and pulling data out of it. So we just add the mut keyword.
We did this to a degree with the git ref thing in an earlier episode, right? Where we're saying like git log and you say main and then like a caret, like not, or what is this again? The hat?
It's a
caret? Is that a caret?
It's a caret.
Yeah, okay. Yeah. So you'd say main not this, or this branch not main, right? And so the rev walker has these two functions. One is push, and one is hide. Yeah. And the push is essentially listing it on the command line, and the hide is putting the caret in front of it. Like don't get anything that's reachable by this, right? So that's what we're going to do here. We're going to push the branch, and we're going to hide the main. Yeah. And just see what the difference is.
So I can just call push on this. It needs to take an OID, so I can just say main branch.get to get the underlying reference, and then I can say .peel to commit. So this is saying find me what is the top commit of this branch. Right. So I just need to unwrap that because it's actually looking up the object, which might fail. And then I can just call .id to actually access the commit ID.
Simple as pie.
Indeed. It's actually really not that bad because a lot of these interfaces follow a very consistent.
Well, I mean, I guess the problem here is that branches can point to lots of things, right? Right. And so it could point to a tag, probably. Right. It could point to a commit. It could point to, like, whatever. So now we're just trying to say, just go through everything you can and try to figure out if there's a commit there, and if there is, give us the SHA.
And I think I've actually done this the
and one then way. Say we don't care about anything that's reachable by that.
Yeah. So I made a small mistake. I put main branch, but we actually want to start off with the the actual.
And then we want to do the same thing to hide anything that's reachable from the main branch.
Yeah. So here we just say the walker dot hide, and then we do basically the same set of incarnations. So we say main branch dot get dot peel to commit dot unwrap.
I hate to do this to you again.
Oh my days.
But you said incarnations. And would it not be incantations?
That was actually wrong. I actually made
the other
a mistake.
one was actually wrong too, I'm pretty sure. But we can't, I forget what it was, so we can't argue about it now. Okay, so you do your incarnations, and then what?
God. Oh my days. So then I can just say Walker, and this just acts as a sort of Rust iterator, which is like a standard set of functions.
Right. So this is gonna it's like a git log. It's gonna give you back in a list sort of every commit that's reachable from the one. That's not reachable from main. Right.
So I could go over these in a for loop, but I think for this example we just want to know how many there are. Right. So we can make use of the count function, which just goes through and counts up how many things get returned. So I'll do that.
I actually didn't know that.
Yeah. So it's similar to like the enumerators in Ruby. Yeah. So I'm just going to say let, this would be the ahead.
Yeah, that'd be ahead, yeah.
So I'm going to just add this to my output structure. So we say ahead is a use size, which is sort of just the standard size of the system. Right?
System int?
Yeah. So this would be like a... it would be assigned, I think, 64-bit integer. Right. And now I just want to say that ahead is ahead. So this is like a shorthand to say I've got a variable that's
a head colon a head.
Yeah, exactly.
You don't have to double it up.
Yeah. And now we can just go into the front end.
Right.
And we can also just add a head here. And in TypeScript, this is just a number. And now we can go down to our for loop, and we can sort of add this as a extra thing that we display. So I'll just put these in paragraph tags so it's formatted a little nicer. So we can basically do the same thing, but rather than getting the reference, we can just say a head, head by, and now whenever I hit this button, it tells us that branch 1 is a head by 1 commit.
2.
Oh, shit. Head by 2, sorry. Yeah, so we've got a number of how far ahead each one is.
Right. Nice. Okay, now we'll do the same thing as behind, and then maybe we'll wrap it up.
Sounds good.
Okay.
So I just want to make a new walker, and Rust has this really cool feature where you can sort of shadow a variable. So if you say, I'm done with this version of the walker, I can redeclare, so I can say let walker equals, and it sort of creates a new version of the walker variable, which is a sort of really handy feature. So I'm just going to copy these last 2 statements, because all we need to do is just flip main branch and the other branch, and I can now just get my behind sort of count. If I try hard enough. So that acts as the behind. So I'm just going to declare these in sort of our sort of input and output structures. Thank you.
We're almost
We'll
done.
make you a good butler yet.
We're almost done.
Come on. I'm sorry. So now, whenever we click this button,
They're all behind by 2.
Yeah,
because there's a couple on the main branch.
correct.
So this is great, right? Now we have the head behind information for all our branches. Okay, so we have an almost perfect Git client
It's nearly as good as Git butler.
that we've built now, and we can create distributions for Mac and Windows and Linux, and they all work perfectly with essentially no help or difficulty in creating and distributing them. Great.
That is so much of a lie.
It gets us a lot of the way there. It's better than doing this in Swift and whatever.
It means we don't need to do different languages for different platforms.
Right. And it's not that bad, actually. If you're really interested, if you do build your own thing, you can go into our Discord and ask us for help on stuff, because we have created a nice app that is built on all this technology that does libgit2 and Git Oxide and does a lot of really complicated Git stuff. And we've packaged and bundled and shipped Sign to all of these platforms. But yeah, thank you so much for joining Bits and Booze yet again, drinking our delicious non-alcoholic Verdejo.
Thank you. It's been a pleasure.
and building a nice Git client in Tori and Svelte. Anything else to...
No, I've enjoyed being on. Mate, if you've got any questions about any of this, feel free to join our Discord, ask about any of it, really.
Comment in the comments.
Indeed.
Smash that subscribe button. And we'll see you next time on Bits and Booze. Maybe or maybe not with Caleb. It depends on how many likes this video gets.
My job is relying on this.
And Merry Christmas.